Welcome students. Today we are going to discuss about the performance characteristics of medium transmission lines. So there are three methods are normally available to analyze the performance of medium transmission line. First one is end condenser method, nominal pi method, nominal T method. So all these methods are based on the way how the capacitors are represented for analysis purpose. So in end condenser method, the name itself you can identify all the capacitance value, that is capacitance here is the distributed parameters. So all the capacitance value will be taken at the end of the transmission system, that is at the receiving end, then it is said as end condenser method, or else in nominal pi method. So the network should be in the shape of phi. So the total capacitance will be divided into two equal half. One will be kept at the receiving end and another one will be kept at the sending end. So it look like the symbol pi, so it's called as nominal pi method. So and another one is the nominal T method. In this method the capacitor will be lumped at the mid of the line, so it is called as nominal T method. So now we will see one by one how each method is used for analyze the performance of medium transmission lines. First one, end condenser method. So already I told, in end condenser method the capacitance value will be lumped at the end of this transmission line. Look at here. So where R is the total line resistance and XL is the total line inductive reactance. So the capacitance value will be lumped at the end of the line. So assume the charging current will be IC. So at the receiving end, the voltage will be VR and the current will be IR. The total power may be as a three phase PR equal to root 3 into VR IR cos pi R is the total load value. Usually the load will be lagging, so definitely the cos pi will be the lagging in nature. Now I am going to analyze the value of Vs and Is and then find out the value of efficiency and voltage regulation of the given transmission line. So for the analysis purpose, it's necessary to draw the phasor diagram. So phasor diagram we will start from the end of the line. So VR usually you will take it as reference value. So always the power factor is lagging in nature, so you are taking VR. So IR will be lagging in nature. That angle is the power factor angle, that is receiving end power factor angle phi R. So immediate to IR the current IC, so it is a capacitive net, so 90 degree IC you will get. So sum of IR plus IC will give the sending end current Is. From the diagram, so look at this. So this is the node point. So incoming current is Is. So outgoing current IC plus IR. So Is equal to sum of IC plus IR. So sum of IR and IC you will get Is. So now look at, come to drop. So one drop is across line resistant and another one drop is across your line inductance. Sum of these two drops with the receiving end voltage, you will get the total sending end voltage. So the drop Is into R will be in parallel with your Is line, because resistance property, both voltage and the current are in phase. Is into R. Next inductive property, 90 degree out of phase shift. So from that line Is RS drop, take 90 degree and draw Is into XL. Now IR, sorry, VR drop across your resistance, drop across your inductance. So all this sum value will give the sending end voltage Vs. So look at the diagram. So first you are take VRS reference, and then current IR at an angle of phi R, and then IC 90 degree out of phase shift capacitive current, charging current. So sum of phi R and Is will give IC will give Is value. Now coming to drop, so Is into R drop in phase. So this line will be in phase with your line Is. Keep in mind. So again out of 90 degree Is into X value. So sum of VR Is into R, Is into XL will give Vs value. The angle between Vs and Is is the sending end power factor phi S. Now what about the formula for regulation? Percentage regulation equal to Vs minus Vr divided by Vr into 100. into 100. So formula for efficiency, output power by input power. So output power VR IR cos pi R root 3 into divided by input power, output power plus losses we can write. So V3 VR IR cos pi R. Here what are the losses? So only one loss, that is across your resistance. So here, so IS squared into R is the total loss. So totally three phase is there. So 3 into IS squared into RL is the total loss. So by using this formula, you can easily calculate the value of efficiency of the transmission line. So look at the formulas. So usually from the phasor diagram, that step by step written in formula. So VR is taken as reference, and IR and phi R both are lagging in nature. So IR in a vector form you can write IR into cos phi R minus J sin phi R, and then the formula for capacity current. So it is the reactive nature, so they mentioned in J. So J into omega CVR. So sum of IR plus IC will give total sending error current, and then drop across each line. So one drop is IS into R, drop across your resistance, and another one drop is I into JXL, that is a reactance drop. So total voltage equal to sum of drop plus receiving end voltage. Therefore, voltage regulation Vs minus Vr by Vr into 100. Efficiency Vr IR cos pi R divided by. This is for single phase line, they mention formula. Suppose the line is three phase line, you simply put root 3. Root 3 into Vr IR. Root 3 into Vr IR. Here, three lines. So 3 into IS squared into R will come. So based on this, you can do for single phase as well as three phase analysis. Thank you.